Hi, I'm Bianca McAllister, and this is Lab 1 Charge Tapes. The goal of this lab was to use real-world methods in order to determine the excess charge on tape to gain an understanding of how charge works. This lab basically shows the interaction between charges by using tape. It's known that when tape is stuck together, there's a neutral charge, and when that tape separates, there is an induced charge on both pieces due to that charge transfer. One of those pieces is going to have a positive charge and one will have a negative. This lab is done to determine how much charge is on a piece of tape after that charge transfer occurs. In order to set this lab up, I created a base tape, two base tapes, and two U-tapes. I placed the U-tapes, which is upper tape, on top of the base tape and ripped them off in order to induce that charge. Therefore, there would be two base tapes with the same charge because they went through the same process. I went through the experiment to determine the charge on the tape. So when I hypothesized that the two U-tapes would have the same charge and therefore would repel each other. And I was correct. I did the experiment, and when I brought the two U-tapes close to each other, they seemed to repel each other, moving away from each other. I also observed the interactions of the U-tape with neutral objects, a table and a book, and the U-tape was attracted to both the book and the table. I rubbed a plastic pen through my hair in order to determine that the charge of the pen was negative. So I assumed the charge of the pen was negative, and then I used the U-tape to see the relationship between that, and the U-tape was attracted to the negative pen, so I assumed that the charge on the U-tapes were positive. And of course, since both U-tapes had the same charge, they repelled each other. What if electrons had a positive charge and protons had a negative charge? The relationships would seem the same, given that the charges would just switch on the objects and would still repel or attract based off the opposite charges, but the actual charge on that body would be different. Why is it important to handle the charged tapes as little as possible? When we touch a charged body, the excess of accumulated charge or that static charges on it gets transferred through our body. So our body acts as a path to it. Thus, the charged body loses its charge and turns neutral. That's why it's important to have a handle on the U-tape when completing these experiments. My data and measurements are listed here. I used a conversion of 1 gram per meter in order to determine the mass on my tape based off of the length of my tape. And also, the separation distance is the distance between the two tapes when one of the tapes began to float. The lab asked some preliminary questions, and I answered them here. What objects in the surrounding exert mainly vertical forces? I said that the gravity exerts a vertical force downward, and electric force exerts a vertical force upwards. Second question, in order to determine the gravitational force on tape B, what quantity do you need to measure? I said you needed the length of the tape in order to determine the mass, and you can see my work here. Determine the magnitude of the gravitational force on the floating tape. Basically, the force of gravity is mass times gravity, so I did that, and then the force of the magnitude of the electric force would just be the absolute value of the F grav that I determined from the mass times gravity formula. In order to determine the amount of charge on one U-tape, I use Coulomb's law, also known as the electric force law. This law comes with a formula which is denoted by the E that I have that you see here. I use separation distance as well as electric force to determine this. I manipulated the formula, and in order to find the Q, I did the math and it came out to 1.654 e to the negative 9 electrons. And in order to calculate the corresponding number of electrons or the excess on tape B, I used a ratio of calculated charge to the charge of an electron to determine this number. As you can see, this is a screenshot of the results of my code. The results of my code are the same as my physical results that I did by hand. There is a visual representation of the forces and the charges. The green sphere represents the U-tape, the blue sphere represents the base tape, the cyan arrow represents the electric force, and the yellow arrow represents the gravitational force. And this concludes the charged tapes labs. And my code link is right there if you'd like to see how I did my code.